Hi everybody, and welcome to exercise 3 on page 17 of the workbook. And in this problem, we're going to try to describe the level surfaces of a few functions just to kind of get the feel for analyzing a function of 3 variables. All right, so let's look at these one at a time, starting with a here. So a gives us a function whose formula is f of x, y, z equals e to the negative x squared plus y squared. Okay, so if we want to analyze its level surfaces, we're going to take the output value, f of x, y, z, and just set it equal to a constant. Okay, we'll do the algebra and see if we can figure out what kind of a shape we're looking at here. So our formula for the function looks like e to the minus quantity x squared plus y squared. That's going to be set equal to c. Okay, and that's kind of an ugly formula that we're looking at. So to discover what we're looking at, we need to do some algebra maybe here. All right, so how do we undo the exponential function? We can take the natural log of both sides. Okay, that's a way of getting rid of the exponential function. So ln of e to the negative quantity x squared plus y squared is just going to give us negative x squared plus y squared equals ln of c. And if we continue with this calculation, we can go ahead and just multiply both sides by -1. And we're going to get x squared plus y squared equals negative ln of c. Okay, so what are we looking at in three-dimensional space? X squared plus y squared equals a constant. You might recognize that as a cylinder centered along the z-axis. We've seen that a couple of times. Okay, now you might be a little concerned about the minus sign that you're seeing here. Okay, because to be a cylinder, we need our radius to be positive. Okay, well, you're right if you look at that and say that we might get a negative number on the right-hand side of the equation, but we don't have to. Okay, for example, this negative ln of c is actually positive if c is a number that's between 0 and 1. Okay, so we will get cylinders provided that c is in this particular range that we're looking at. Okay, so this is going to work for some values of c and not for others. That's kind of the lesson that's coming out of this. Okay, so the level surfaces are indeed cylinders. Centered along the z-axis. Okay. And that's what they wanted, was just a basic description. All right, so let's move on to part B here then. Okay, so what would the level surfaces of g of x, y, z look like? Well, we're going to take our function and set it equal to c. This time that's going to give us z minus y equals c. And then the question is, what are we looking at in three-dimensional space? Okay, if you gave c a particular specific value, what kind of a surface do we get? Okay, actually, because z and y are both raised to the first power, we're talking about a flat surface, a plane. Okay, we'll discuss planes a little bit more in the next chapter. Okay, but in general for now, what we'll say is that the level surfaces of this function are planes. Okay, and finally, let's look at C here. Okay, so the level surfaces of V we would get by taking our function V and setting it equal to a constant. Okay, and so let's see. The formula for our function looks like ln of x squared plus y squared plus z squared. Okay, again, we're looking at kind of a complicated formula. I can't really tell what that's going to give us without doing some simplification. So how would we undo the natural log function on the left-hand side? Its inverse is the exponential function, so we could exponentiate both sides. And we can do that as long as we do the same thing to both sides. Okay, and the e and the ln are going to cancel. We'll just get x squared plus y squared plus z squared equals e to the c. And do you recognize that formula that we're looking at? X squared plus y squared plus z squared. That's the equation of a sphere. Okay, centered at the origin. E to the c is just some constant. Okay, so if we really wanted to, we could do some algebra and figure out what the radius is, but they're just really asking us for a rough description. So in this case, the level surfaces are all spheres centered at the origin. Okay, and the radius of the spheres is going to be dependent on the value of c that we're choosing.